All right. So today we will start with some miscellaneous questions on indefinite integration. All right. So starting with the first question, I'll give you 2-3 minutes to think over it. Integration e to the power x 1 plus sin x upon 1 plus cos x dx. Just give it a thought for a moment. See, I hope something you must have thought. So this is equals to integration e to the power x. You just split the denominator on both the values of numerator. So 1 upon 1 plus cos x plus sin x upon 1 plus cos x dx. So that is integration e to the power x. Okay, that form I have already told you. That's okay. E to the power x. This will be 1 upon 1 plus cos x is 2 cos square x by 2. And this is sin x is 2 sin x by 2 cos x by 2 upon 1 plus cos x is 2 cos square x by 2 dx. All right. So e to the power x. This is half of secant square x by 2 and it will become tan x by 2 dx. Am I correct? Now assume if this is your fx, then this is f dash x. If this is fx, then this is f dash x. So this will be what? Integration of e to the power x fx is the final answer. Yesterday only I told you e to the power x fx. So e to the power x tan x by 2 plus constant. Very simple question. I started with an easy question. Got it? See it once. Now, next question. This is such an important and good question it is. It is x square minus 1 dx upon x under root of x to the power 4 plus 3x square plus 1. Yes. Just give it a thought. Just think about it. Any idea if somebody would like to present? Switch on your mic and speak up. Now see, what I do, bring x square out from the under root. So it will come out as x. So this will become integration x square minus 1 dx upon x square, and inside the root it is x square plus 3 plus 1 by x square. Got it? Now take this x square to the numerator. It will be 1 minus 1 by x square dx upon, inside the root it is x square plus 1 by x square plus 3. Now think for a moment that this, whatever is there in the numerator we have created, this is derivative of which quantity? This is derivative of x plus 1 by x, isn't it? So let us try to create same thing in the denominator. So it is 1 minus 1 by x square dx upon, inside the root I can write it x plus 1 by x whole square plus 1. That 3 I extract 2 and made it x plus 1 by x whole square. Now let us assume this x plus 1 by x is t. So 1 minus 1 by x square dx is dt. So it became integration dt upon, inside the root, t square plus 1. Yes or no? And we have a formula for that is ln t plus under root of t square plus 1 plus constant. And now replace the value of t that you have, that is x plus 1 by x plus under root x plus 1 by x whole square plus 1 plus constant. See the question and the strategy behind it. Have a look at it. Got it? Now, now I'll take an example from NCERT itself. The question is integration dx upon under root sine cube x sine x plus L. This is an 18th question in the miscellaneous exercise of NCERT. Dx upon under root sine cube x into sine x plus L. Got it? All right. What we can do, let us write integration dx upon under root. Keep sine cube x as it is. Okay, first of all, you try it. It's a question from NCERT. At least I expect you will do it. Quickly do. Yes, anybody, if you want to speak up something, any strategy, any method you would like to explore? Mr. Madhukar Reddy. Yes, anybody? See, sine cube x, let me expand that formula. That will be sine x cos alpha minus cos x sine alpha. All right. Now, dx upon, take sine x common from this bracket. So outside you will have sine to the power 4x. Inside it is cos alpha minus cot x sine alpha. I took sine alpha out of the bracket, sine x. Now, take this sine to the power 4x outside the root. So it will become sine square x cos alpha minus cot x sine alpha. Yes or no? The sine square alpha goes upside. So it is cosec square x, sine square x goes upside. Cosec square x dx upon inside the root. It is cos alpha minus cot x sine alpha. Got it? Now, if you realize alpha is constant, but this cot x, which is variable, its derivative is cosecant square x minus cosecant square x. So let me assume the entire thing that is in the denominator, that is cos alpha minus cot x sine alpha as t square. So its derivative will be sine alpha into cosecant square x dx as 2t dt. So this will be what? Numerator is 2t cosec alpha dt upon downside it is t. Now this t and t cancel. 2 cosec alpha outside, you are left with 1 into dt. Integration of 1 is t. So 2 cosec alpha into t plus constant. And t is what? Under root of cos alpha minus cot x sine alpha. So it is 2 cosec alpha under root of cos alpha minus cot x sine alpha plus constant. This is your answer. See this question once. Got it? Now, let's go with a different variety of question. This is like integration dx upon x plus 2 under root of x plus 1. It's like linear outside, linear inside the root. Got it? Linear outside, linear inside the root. So a very common substitution for this is whatever there is linear inside the root, assume it as t square. So assume x plus 1 as t square. All right. So dx you will get as 2t dt. So now the question will become dx is 2t dt upon x plus 2 will be what? T square plus 1 and under root of x plus 1 is t. 1 t cancel. So it is integration 2 dt upon t square plus 1. That is 2 outside integration dt upon t square plus 1. And this integration is, we all know, that is tan inverse t plus constant. That is 2 times tan inverse of under root of x plus 1 plus constant. Am I clear? So make it a simple rule. If the question is of this type, integration dx upon ax plus b under root of px plus q. Linear outside, linear inside. Then take px plus q as t square. Very effective tool it is. Got it? Now, let's go with another variety. If it is like integration dx upon linear outside and quadratic inside, like x plus 1 under root of 1 plus x minus x square. So what it is? If it is like integration dx upon ax plus b under root of px square plus qx plus r. If it is of this type, linear outside, quadratic inside, then the substitution is that linear ax plus b, assume it as 1 by t. Now, if when I have told you the substitution, try this question on your own once quickly. Quickly do. How do we do it? Let us assume x plus 1 as 1 upon t. So dx is what? Minus 1 by t square dt. Am I correct? So this is equals to integration minus 1 by t square dt upon, this is 1 by t, and inside the root it is 1 plus x is 1 by t minus x is 1 by t minus 1 whole square. Got it? So it is minus 1 by t square dt upon 1 by t. 1 t we can cancel out, so we'll do it in next step. Now it will be minus 1 by t square plus 3 by t minus 1. Now if you further take LCM, it will be integration minus of dt upon under root of minus t square plus 3t minus 1. Am I correct? So now let's complete the square. Minus dt upon inside the root minus t square plus 3t, half coefficient of t 3, half of that 3 by 2, square of that is 9 by 4, add 9 by 4, subtract, and minus 1. So minus dt upon inside the root, it will be 9 by 4 minus 1, that is 5 by 4 minus t minus 3 by 2 whole square. Got it? So here I use the formula of integration dx upon under root a square minus x square, which is sine inverse of x upon a. So it will be sine inverse of t minus 3 by 2 upon under root 5 upon 2 plus constant. That is sine inverse of 2t minus 3 upon root 5 plus constant. And then this t is replaced by 1 upon 1 plus x. So it is sine inverse of 2 upon 1 plus x minus 3 upon root 5 plus constant. See the question. Got it? Now, next question. Say I equals to integration dx upon sine x minus 3 cos x minus 1. See, you have this kind of expression to solve. Now what to do? Think for it for a moment. See, whenever we have this kind of factor in the denominator, like a sin x in the denominator, we have a sin x plus minus b cos x plus minus c types of factors. They are also plus minus sign. Then convert sin x and cos x into half angle of tangent formula. Like sin x को we will replace 2 tan x by 2 upon 1 plus tan square x by 2, and cos x we will replace 1 minus tan square x by 2 upon 1 plus tan square x by 2. Got it? So this I will be integration dx upon, now sin x is 2 tan x by 2 upon 1 plus tan square x by 2 minus 3 times 1 minus tan square x by 2 upon 1 plus tan square x by 2 minus 1. Now if you take LCM, this 1 plus tan square by 2 will go in the numerator and will become secant square x by 2 dx upon 2 tan x by 2 minus 3 times 1 minus tan square x by 2 minus 1 plus tan square x by 2. Now there will be a substitution. Assume tan x by 2 as t. So in that case, sec square x by 2 into 1 by 2 dx will be dt. So sec square x by 2 dx became 2 dt upon 2t minus 3 plus 3t square minus 1 minus t square. So it became 2 dt upon 2t square plus 2t minus 4. Got it? That is integration 2 dt upon, this became t square plus t minus 2. 2 dt upon, it is t plus 2 into t minus 1. Now partial fraction can be done very easily. So it will be, in the numerator I write t plus 2 minus t minus 1 dt upon t plus 2 t minus 1. In the numerator 3 came extra. Just a moment please. Sorry guys. So this is like this. 2 is already there. So it will become 2 by 3. Got it? Just a moment. There was a 2 in the denominator also. Now I took common. So it is 2 into 3. 2 will cancel out now. So it is 1 by 3 integration 1 upon t minus 1 minus 1 upon t plus 2 dt. So this will be 1 by 3 ln of t minus 1 upon t plus 2 plus constant. You may take mod of it. And then replace t as tan x by 2. Just have a look at the entire question in one way. See it once. Got it? Now, let's go with the next question. If the question is like integration dx upon 3 sin x minus 4 cos x whole square. Dx upon 3 sin x minus 4 cos x whole square. Now see, as a variety, if denominator is having terms of sin square x, cos square x, sin x cos x or constant, then what do? We multiply numerator and denominator by secant square x. We multiply numerator and denominator by secant square x. Now, here also if I multiply and divide by secant square x, numerator will become secant square x dx upon denominator will become 3 tan x minus 4 whole square. Got it? Now, simple thing to do, assume 3 tan x minus 4 as t. So 3 secant square x dx will become dt. So numerator became dt by 3 and this will be t square. So dt by t square integration is minus 1 upon t plus constant. So answer is minus 1 upon 3 and t is 3 tan x minus 4 plus constant. Got it? Now, next question. See, we have integration dx upon x into x to the power n plus 1. Think over it. Think for a minute. Quickly think. Now see. Take x to the power n common. So x is already there. You took x to the power n common. It became 1 plus 1 upon x to the power n. Got it? Now, this became what? 1 upon x to the power n plus 1 dx upon 1 plus x to the power minus n. Now, derivative of denominator is there in the numerator. If I assume 1 plus x to the power minus n as t, so minus n x to the power minus n minus 1 dx becomes dt. So dx upon x to the power n plus 1 is minus of dt upon n. So it became what? Dt minus dt upon n as well as t in the denominator. So answer is what? Minus 1 by n ln t plus constant. So it is minus 1 by n ln of t is what? 1 plus x to the power minus n plus constant. This is your answer. Got it? Am I clear? So it was a simple variety. Now let's take in another very good example. It was a previous year IIT question. Integration x to the power 6 plus x to the power 4 plus x square into 2x to the power 4 plus 3x square plus 6 under root of this dx. Think about it once. And while you are thinking about this question, in the meantime, just mark this poll also. Yeah, please quickly, so that we start discussing this question. Don't go anywhere. We are here to discuss this. No, bye bye. Anyways, thank you so much. Now let's go with this question. See, there is no direct field. Getting my point? But yes, one thing we can do, if I extract x from this bracket, what I will be left with? X to the power 5 plus x cube plus x. And then transfer that x to the under root side. It will go x square inside. So it will be under root of 2x to the power 6 plus 3x to the power 4 plus 6x square dx. Tell me yes or no. And now if you see, if I assume it as t square, its derivative is written outside. That means 2x to the power 6, 3x to the power 4, 6x square as t square. Its derivative will be 12x to the power 5 plus 12x cube plus 12x dx equals to 2t dt. That means x to the power 5 plus x cube plus x dx is t dt upon 6. So your question became, this under root is t and x to the power 5 plus x cube plus x dx is t dt upon 6. Now 1/6 is there. This integration will be t cube upon 3 plus constant. So your answer will be 1/18 2x to the power 6, 3x to the power 4 plus 6x square raised to the power 3/2 plus constant. This is your answer. Am I clear? Have a look. This is a very good question. So in today's session, the kind of variety we have covered, it's a huge variety that I try to cover today. First was this one, e to the power x fx plus f dash x. That ultimately results into integration e to the power x fx. Then force substitution. You bring out something and you make it something so that we can substitute it. Then same type, taking something common and creating the substitution. Then linear outside, linear inside the in the denominator. So what I tell you, whatever is there inside the root, make it as t square. Then linear outside, quadratic inside. So the substitution I told you that this linear should be assumed as 1 upon t. Then if there are factors like sin x, cos x, constant, only these in the denominator, a sin x plus b cos x plus constant c times, then convert to half angle of tangent. Convert to half angle of tangent. If there are second degree terms of sin square, cos square, sin x, cos x or constant, then multiply numerator and denominator by secant square x. Again, same, taking something common and creating a good substitution, and same thing here. So that would be all from me today. And do these questions on your own again. Only then it is actually going to help you. Otherwise, these methods we forget very soon. All right.